Dear friends, in the previous video we discussed about multiple alleles. For watching the same video we can provide you a link in the comment box. Now in the second part we are going to define how to calculate pheno and genotypic ratio by using different formulae. Now let us start the concept. Now first of all let us talk about phenotypes. Means number of phenotypic ratio can be calculated by using symbol capital N. Here the N indicates total number of multiple alleles present in a gene. We have one more formula to calculate number of phenotypes when there is a gene interaction between multiple alleles. The formula is N plus total number of gene interactions. Here the gene interaction we consider is incomplete dominance and codominance. Now let me simplify the second case here. Let's assume we have 8 multiple alleles for a gene. Among these alleles, one loci we can say 2 alleles show complete dominance effect. Dear friends, complete dominance is not considered as a gene interaction. Now remaining alleles we can write here 6 alleles. Among 6 alleles, one pair of allele shows incomplete dominance effect. Now this is the first gene interaction present. Leftover alleles we can write here 2 pair of alleles show codominance effect. This is second gene interaction. Now we can calculate in 8 alleles we have 2 gene interactions, 1 incomplete, 1 codominance interaction. Dear friends, we can normally apply formula number second to calculate phenotypic ratio. Hope you got the concept. Now to calculate number of genotypes in multiple alleles we have different formulae. N plus 1 divided by 2. Now in the last go we are going to apply all these types of formulae geno and phenotypic to solve some important numericals of multiple alleles. Some important numericals that I am going to underline here. Number 1. 10 multiple alleles control one character. We have simply find total phenotypes and total genotypes present. As we already know that here the gene interaction is totally absent. Now to calculate phenotypic ratio we can use formula number first. So we can write total phenotypes are equivalent to capital N. Here the N denotes total number of multiple alleles present, that is 10. So 10 is the phenotypic ratio. Now calculating the total number of genotypes present. Here we have formula N into N plus 1 divided by 2. Again N indicates total amount of multiple alleles. So we can write 10 into 10 plus 1 divided by 2. Which after calculation can give rise, we can write here 55 types of genotypes. So it was the first example. Hope you got this by all means. Now talking to the second very important case. 20 multiple alleles control one character, in which one loci means 2 alleles shows complete dominance and next allele pair shows incomplete dominance gene interaction. Now the rest of alleles show, we call it as codominance gene interaction. We have to calculate pheno and genotypic ratio simply. As already discussed, here are 2 important gene interactions, one incomplete dominance, another codominance. So the phenotypic ratio can be calculated by formula number second, means 20 plus 2, 20 multiple alleles plus 2 gene interactions. It is equivalent to 22 phenotypes. Now calculating the genotypic ratio, we have formula N into N plus 1 divided by 2. Here the N denotes total number of multiple alleles, 20 into 20 plus 1 divided by 2. By calculating its value, it will give rise a here number 210 types of genotypes. Now let me add 2 important examples, or we can say numericals, to this whole topic. One of the prominent numerical is ABO blood group system in human beings, as we have already read it. It is controlled by 3 multiple alleles IA, IB, I0, among which one multiple allele pair shows complete dominance. and one shows codominance. Now we have to calculate here phenotypic and genotypic ratio. It is very simple to understand now. By calculating phenotypic ratio, we can use formula number second because here gene interaction 1 is present in the form of codominance. So we can write total multiply alleles 3 plus 1 gene interaction. It will give rise 4 phenotypic ratio. You know 4 phenotypes in ABO blood group. They are A, B, AB and O. And the genotypic ratio will be n into n plus divided by 2. Here the n is total 3. We can write here 3 into 3 plus 1 divided by 2, and its value will come in the form of digit 6. So we have 6 genotypes. Let me write it here. For A blood group, we have genotypes IA, 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 I0. For B blood group, we have IB, 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 I0. And for ABO blood group, we have IA, IB. Accordingly, for O, we have IA, I0. These are total 6 in number. Now, last one example here to discuss is coat color in rabbit. It is controlled by 4 multiple alleles. Among these alleles, one allele pair shows incomplete dominance. We have to calculate pheno and genotypic ratio. Now here in this case, one gene interaction is present in the form of incomplete dominance. So we have to calculate phenotypic ratio. We can use second formula, means n plus total gene interaction is. The value of n is 4. One gene interaction is present. 5 phenotypes are total. Here we can write agouti, chinchilla, Himalayan, albino and light grey. Now what will be the genotypic ratio? You know there is formula n into n plus 1 divided by 2. Here n is 4, 4 plus 1 divided by 2. As we already know that in coat color of rabbit, total genotypes arise are 10. Dear friends, it was second part of multiple allelism where we discussed different types of numericals. If you find this video by any means valuable, kindly share and never forget to subscribe. Thanks, have a nice day.